Welcome back to RDWorks Learning Lab. I've been using the machine, but I've never bothered to check the mirror alignment. If you can follow the instructions in the manual, then I suggest you've got superhuman powers of understanding. You're supplied with what looks like a reel of white PVC type tape. Bearing in mind that I've already mentioned to you, PVC, when you burn it, produces toxic fumes. I'm a little reluctant to use the tape they've supplied, even though there is a video which shows you how they use it. It's a very imprecise method. Hopefully what I'm going to show you here is a way of aligning the mirrors really accurately. So to do that, we're going to have to come here to our good old RDWorks, and we're going to have to design some little pieces of perspex. Now the pieces of perspex are actually going to be targets which sit in the apertures in front of the mirror. I've already been out and measured my machine, and I know that the first aperture that I want to measure into the first mirror is about 21.5 diameter. We're going to start with a circle, and we're going to put a circle in control, and we need to make that circle black, which it is at the moment. We will adjust its size. We'll make sure we put the lock on, and then we'll adjust its size to the size that we want, 21.5. So let's just zoom into the circle a little bit, and we'll put a line approximately down the center. As you can see, I'm purposely put it off center, but we will have it upright with the control key, and we'll put another line across center, and again I'm purposely off center, and I want to stay inside the circle, so we'll make it horizontal. Click like that. Now we'll bring this back to normal size. There we go. And what we really now ought to be doing are these lines. Click and shift to mark them together. We'll make the lines red. So we're now going to draw some circles, and we can do control copy, and then we'll do control V, control V, control V. So that'll be 12, 10, 8, 6, 4. We'll join those together, and we'll make all those red, and then we'll work on this one, and we'll reduce its size to 12. Then we'll reduce the size of this one to 10, and this one here as 4. Now we're going to turn this into a target. So all we need to do is to marquee the whole lot, and we'll put everything onto a vertical center line. Click. And now we'll put a marquee around it again and put everything onto a horizontal center line. Click. And there's a quick way to make our target. Let's move this up to the corner here. Then we'll put a marquee around it again. Hopefully the whole lot is now marked, and we will turn that into a group. Okay, so now when I move the outside circle, the whole lot moves. So I've got a group. So we can do control copy, knowing that we're copying the group. We'll put one down here, control V, and then we'll put some along here, control V. So we'll go around this one, and we will ungroup that one, because we need to go to that diameter there and change, it's the whole, yes, right. We need to change that diameter there from 21.5 to 18, because that's the other dimension that I've measured I need a target for. So we've reduced the outside dimension to 18, but we've still got two layers here, a red layer and a black layer. So the black layer we need to be cut, so let's just check the parameters for the black layer. Is it an output? Yes. Speed 12, that seems like a reasonable speed. Is it cut process? Yes, it's cutting, and we'll have the power at 90/90. So there's a good settings. Okay, let's check the what I call the etching layer now. because we want to just etch the target and the crosshairs onto a piece of acrylic. So is it output? Yes. Speed? Yeah, 50. Might be a bit fast for the inner circle, but I think it'll deal with it. Process mode, cut. Well, it is going to be cut, but we need to cut it fairly fast, and we need to cut it at fairly low power. 15% and 15%. That seems low enough. And we'll say OK. Now the only problem here is we've got a cut layer above an etching layer. So we need to pull the black layer below the red layer. So we etch the red parts on first, and then we cut the outer shape out into targets. Okay, so that will apply to this as well, but we need to group this because we want to make several of these as well. So we will group that, and then we will copy it. Control copy, Control C, Control V, and Control V. How many is that? 3, 6, 7. One more makes 8. Now these all look a little bit higgledy-piggledy. So what we do, we'll group these together like this, and we'll ask it to be on a common horizontal center line, like that, and then we'll put them as a nice even spacing like this. So we need to choose them again. We'll put some even spacing between them. Click. Oops, we missed one. Horizontal center line. And nice even spacing. Now before I actually designed this program, I cut a 21.5 diameter circle on the machine, and I found that it came out at 21.15 millimeters rather than 21.5. So if we divide 21.5 by 21.15, we finish up with 101.6%. We'll leave the files locked so we get the ratio the same in both directions. We want to move it by 101.6. Enter. And that makes the whole lot just a little bit bigger, so that when we cut it, it cuts under size and finishes up the correct size. There is another way of doing that, and if we look at the black cut command up here, we'll find that we've got something down here called seal. And if we click advanced, we'll find that we've got enable something called sew compensation. And basically what this is an adjustment that allows the lacer line to move in or out from the design line, and we can compensate in or out by an amount that we specify here, which would be slightly more accurate than what I've done there, because what I've done, I've applied a percentage compensation to the smaller diameter as well as the bigger diameter, and the smaller diameter won't have quite the same compensation. It'll still be slightly wrong. It's not going to be a problem in this particular instance. Save everything now and off to the machine. Give it a little bit of air assist, and away we go. Enter. Notice the way it's intelligently sorting out its own paths. As you can see, I've put a piece of masking tape across the top of the target so as not to obscure the target, but that should allow me to drop that into the hole there. Now I'm going to turn the laser on again, and I'm going to hit it with a pulse. I think you can see the pulse clearly was centered somewhere at about 1 o'clock, but well off center. We'll do that one more time so you can see it. Now although the laser beam has come out and not hit that target centrally, I don't think it really matters, and it's not far off centre. I think it's the next stage which is the important stage. Now the first thing we're going to do is to take this as close as we can to the beam as it comes round this first mirror. So let's turn the laser on and we'll do a pulse. What we really ought to do is now have a look to see where that pulse has gone. We'll carefully take that off there. And we can see that the pulse clearly is at around about 2 o'clock and a whole beam width off centre. So we put that back approximately where it was, and now we're down at this end of the stroke. Now we do another pulse and see where that comes. And we can see that again it's actually not badly aligned, because it's spot on the same position. It might not be in the middle of the target, but we've still got a round circle, not an oval, i.e. the two beams are coincident. So we've got a beam that's on a position in the target this end, and it's on the same position at the target at the other end. So the beam is actually aligned, it's horizontal. So now what we've got to do is exactly the same thing in these two positions. In other words, what we need to do is check whether or not the beam comes out here and is parallel to this one at each end of its stroke. We were looking for the beam to be on centre, whereas the beam doesn't actually have to be on the true centre. It just has to be in the same position on both targets. So let's run to this end of the stroke. Give it a pulse. Now we move it to the other end of the stroke. Now if we look here, you'll see that the lacer has just nicked the top of this tape. So that's where the lacer beam was at the other end of the stroke. Let's see where it is at this end of the stroke. We'll do a pulse and see what happens. Well, the answer is, although it's high, it's perfectly lined up. So we don't have an oval shape, we have a round shape, which means that the two beams must be coincident. So now that we've proved that we've got the beams lined up, it doesn't matter where we do the final test. So I've probably got that touching the surface. Let me move it away about 1mm. Right, so the camera is now lined up with the head. And we should see the pulse coming right down the centre of the nozzle. Let's just move the head back a shade, and then we can see whether or not it's down the middle of the nozzle. I think you can clearly see there from that reflection that the beam, the hole, is slightly that way. So if I turn and adjust the head very slightly, adjust the mirror, hopefully I'm setting the mirror in a different position to make the pulse go in a different place. See, each one of these has got a locking screw on it, and I'm wondering whether these actually need to be loosened off to get adjustment. Here we go. So you'll notice I'm doing what every bloke in the world does, which is ignore the manual. So let's just loosen that off. And I do believe that adjusts it now. So let's go back and do another test. Pulse. A little bit more. Pulse. And do you know what? I do believe we're pretty well on centre. Now that's not as sensitive as I thought it was going to be. I thought it was going to be pretty crude, that adjustment at the top there, but it isn't. So hopefully you can see, I think, that illuminated little red dot on the end there, which is the hole that's been pierced, is pretty well on the centre of the nozzle now. And now we do some pulses in this direction. So we do a pulse, move the head so we can see where it is in relation to, and to be honest, that doesn't look far out, that looks pretty reasonable. So I'm going to lock the head up in that position, lock that little screw up, and say that we've lined everything up.